Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today I want to discuss about loss of wear topic, and then we will discuss numerical problems related to this loss of wear topic. So already we have seen in wear topic, and already we have discussed more question bank on this. Now in this only we will concentrate on numerical problems related to this loss of wear. Numerical problems related to loss of wear topic. So Archer's wear law calculation. About law already you know. So how do you calculate the wear volume of the material? By using this Archer's law, wear law. A material experiences a wear rate of 1 into 10 to the power minus 6 meter cube per Newton meter. 1 into 10 to the power of 6 meter cube per Newton meter. So under a normal load of 200 newtons and a sliding distance of 500 meter, calculate the total wear volume of the material. So the wear volume is wear rate, normal load and sliding distance. So the volume is wear rate multiplied with the normal load multiplied with sliding distance. So the material, the given rate, the wear rate already given 1 into 10 to the power minus 6. Substitute in this. Normal load is 200 newtons, and then sliding distance is 500 meters. So now you will get 1 into 10 to the power minus 6 multiply with 200 and 500. So here you will get finally 10 to the power minus 2. This is the wear volume. Calculating wear using the Peters law. So according to Peters law, the wear rate is proportional to the sliding distance and inversely proportional to the load. If a material wears at a rate of 0.01 mm cube per Newton meter under a load of 100 newtons and a distance of 1000 meter, calculate the wear rate when the load is increased to 150 newtons and the sliding distance is 2000 meters. So according to this law, the wear rate is proportional to the sliding distance and inversely proportional to the load. So use the proportional relationship. The wear rate is equal to wear volume upon normal load multiplied with sliding distance. Adjust the wear rate for the new load and distance using the proportionality. The distance using the proportionality. So the wear rate and wear volume upon normal load into sliding distance. So by using this relationship, you can calculate calculate the wear rate by using this Peters law. So how do you calculate? Wear volume upon normal load multiplied with sliding distance. Next, estimating wear volume using the Archer's wear law. The wear volume using this law, Archer's wear law. So an experiment shows that a material has a wear coefficient, that is K, 5 into 10 to the minus 6 cube per Newton meter. If the material is subjected to a normal load of 300 newtons. and a sliding distance of 200 meters. Calculate the wear volume. So already you know, according to this law, the wear volume is K multiplied with normal load and sliding distance. So the normal load is 300 newtons and sliding distance is 200. So now substitute here 5 into 10 to the minus 6 multiply with the normal load 300 and sliding distance is 200. So you will get 30 multiplied with 10 to the power minus 6 into 10 to the minus 10 to the floor. So 30 multiplied 10 to the minus 2. So the wear volume 30 by 100. So 0.3. 0.3. So what are the units here? mm cube and then 300 newtons, 200 meter distance, sliding distance. So this in terms of mm cube volume will get. Wear rate and load dependence. A material exhibits a wear rate of 2 into 10 to the minus 5 mm cube per Newton meter. Under a normal load of 500 newtons and a sliding distance of 1000 meter. If the load is increased to 750 newtons, so the normal load is 500 and load also increased to 750. So how does the wear rate change? Assuming the wear rate is proportional to the load. So the material exhibits a wear load given, normal load available and sliding distance and increase it to 750 newtons. So the wear rate is proportional to the load. So the solution is use the proportionality. The new wear rate is equal to old wear rate multiplied with new load by old load. Cumulative wear calculation using law of wear. So the cumulative wear calculation using law of wear means a material has a cumulative wear volume of 1 mm cube after 500 meters of sliding under a normal load of 100 newtons. If the wear rate remains constant, what will be the cumulative wear volume after 1000 meters? The normal load is 100 newtons. If the wear rate remains constant, and he has asked what will be the cumulative wear volume after 1000 meters, so what is the wear volume? So here cumulative wear volume calculation formula is given, wear rate multiplied with the normal load and sliding distance. First need to calculate the wear rate from the initial data. Then use it to find the cumulative wear volume for the new sliding distance. First you need to calculate the wear rate by using initial data and then find the cumulative wear volume. So the wear volume calculation using wear test. So another testing that method is there, wear test. So how do you calculate the wear volume? So the wear test shows that a material wears by 0.1 mm cube under a normal load of 50 newtons and a sliding distance of 200 meters. Calculate the wear coefficient using Archer's law. The solution K is wear volume upon normal load into sliding distance. Where volume substitute the given values to find the wear coefficient. So in this, you can find the wear coefficient. So next, impact of sliding speed on wear. So an increase in sliding speed of speed from 0.0 meters per second to 1.0 meters per second. The sliding speed initially meter per second. So V2 is 1 meters per second. Doubles the wear rate of material. If the initial wear rate is the wear rate is 10 to 1 into 10 to the power minus 5 mm cube per Newton meter. Calculate the new wear rate after the speed increase. So a new wear rate is equal to old wear rate multiplied with 2. So new wear rate is equal to old wear rate. So the old wear rate is here given 1 into 10 to the power minus 5. Multiply with 2. So you will get new wear rate after the speed increase. Next, wear rate and material hardness relationship. A material with a hardness of 200 HP has a wear rate of 10 to the minus 6 mm cube per Newton meter. If the hardness increases to 300 HP, how does the wear rate change? Assuming wear rate decreases proportionally with the increase in hardness. So the wear rate decreases proportionally with the increase in hardness. So what is asked, how does the wear rate change? So use the proportional relationship here. New wear rate already know. So formula old rate multiply with old hardness. In previous they calculating the new wear rate after the speed increase you have to multiply with 2. But here in hardness case new proportional relationship is old wear rate multiplied with old hardness. Next, hard coating thickness. How do you calculate the thickness of the coating? So a hard chromium coating is applied to a metal surface with a thickness of 0.02 mm. If the coating process has a deposition rate of 0.05 mm per minute, calculate the time required to achieve this coating thickness. So the time is coating thickness upon deposition rate. Coating thickness upon deposition rate. So coating thickness, the thickness of the coating given 0.02 mm. If the deposition rate is 0.05. 0.005. So now calculate the time required we will get. So here coating thickness 0.02 coating thickness divided by deposition rate is 0.005. Now 2 by 100 multiply with 1000 by 5. So then get cancel here. 5 4. This is minutes. 4 minutes. The time required to achieve this coating thickness. So no. Suppose you have to apply the coating, the thickness 0.02 mm required. The time is 4 minutes. Similarly, carburizing depth calculation. The steel component is carburized, this heat treatment process, at 900 degrees centigrade for 8 hours. If the diffusion coefficient D of carbon in steel at this temperature is 1 into 10 to the power of 11 meter square per second. So calculate the depth of carburization achieved. assume fixed second law of diffusion applies and use the formula. So here carburizing depth calculation, the fixed second law of diffusion formula is x is equal to square root of dt. So convert the time into seconds now. So 8 hours given, 8 hours multiply with 860 multiply with 60. You will get in seconds. They calculate the depth, that is x square root of d into t. Carbon steel at the temperature is 110 to minus 11 multiply with t. The time is 28,800 seconds. So we will get x value. So as per fixed second law, you can calculate the carburizing depth calculation. So next, surface roughness measurement. So metal surface is treated to achieve a roughness of 0.5 micrometer roughness average value. If the initial roughness was 2 mmRA, calculate the percentage of reduction in surface roughness. Already we have seen in surface roughness calculation part. So here percentage reduction is initial roughness value minus final roughness by initial roughness value. So here percentage reduction, you can see the initially given 2 and then roughness is 0.5. So 2 minus 0.5 upon by 2 multiplied with 100%. So you will get the surface roughness measurement. Yeah. So like this, you need to calculate some measurements, the heat treatment method calculation, heat treatment carburizing depth calculations, and a roughness measurement, and then coating. The coating methods, how much thickness is required and how much time to achieve the proper to achieve the required coating thickness. So like this problems will ask in examination. So need to remember the formula how to calculate and then apply this formula for your problem and substitute the given values. For any problem, first you should write the given value and then start the solution. So these are the some numerical problems related to this wear and surface treatment. The references I have taken on these 3 textbooks and refer. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.